All right, hi guys. Here is a video for Module 9 review for IM3. So we're going to review simplifying rational expressions, multiplying, dividing, adding, subtracting, and then solving rational equations. Okay, so we're going to start off simple. We are just simplifying. So all we're doing, and really what we're doing for all of these, is starting off by factoring. Always, always, always factor first. So I see in my numerator, I've got a trinomial. Let's factor that. So we're going to see if our guess and check is going to work. Let's see if we can factor it like this. Let's see what factors of 24 are going to add up to 10. Well, I have 3 and 8, and those aren't going to add up to 20 or 10. I have 6 and 4. Okay, those are going to add up to 10. So I can factor this as x plus 4, x plus 6, and then don't forget your denominator. This is already factored, it's just x plus 4. Okay, so you'll see now that I have x plus 4 and x plus 4 in the numerator and denominator. Now these factors are being multiplied, so I can absolutely cancel these, and all I'm left with is x plus 6. So that's my final answer. Don't forget, you could have excluded values. Look back at your original problem. What value would make this denominator 0? And that would be -4. So x cannot equal -4. All right, next one. Again, factor, factor, factor. Denominator is already factored, but I can rewrite this numerator. Well, I see that both of these terms have a 7 in common. So I'm going to factor out a 7, and what's left is x plus 3, and then write your denominator. All right, so you'll see now here, my x plus 3's are going to cancel, and I just have 7. So 7 is my simplified answer, but don't forget, our original problem had a denominator, and so x cannot equal 3 here. All right. Now I've got another binomial, so 2 terms. Again, let's see what numbers I can factor out. Well, I can definitely factor out a 2 because those are both even. And I know 6 goes into 12. Ooh, and it goes into 30 as well. That's a factor of each number. So I'm going to factor out a 6. And then what's left is a 5x minus 2 all over 36x squared. Now, my binomial right here is not going to cancel with anything. But I do see that I have a 6 here. So that's going to factor to a 1 if I cancel the 6. And then if I factor out a 6 out of 36, I have a 6 left. So then my final answer would be 5x minus 2 in the numerator and a 6x squared in the denominator. Then you're done. So this is your final answer. And then last but not least, your excluded value, x cannot equal 0 here. All right, last one for simplifying. We've got, again, a binomial and then just a number. So I'm going to go through and see, all right, well, I can definitely factor out a 1, but that's not going to do anything. I can't factor out a 2. Ooh, but I can definitely factor out a 3. So I've got 3, and then v minus 5 is left, all over 24. And then don't forget, 24 is a multiple of 3. So we can rewrite this if you want to see how I'm factoring this. 3 times v minus 5 over, and I'm going to factor 24. I'm going to write it as 3 times 8. So you'll see the 3 and the 3 cancel, and I have v minus 5 over 8 as our final answer. This one does not have an excluded value because my denominator is just a constant. It's 24, and so no value of v is going to make this 0. Alrighty. So our next section is adding and subtracting. So don't forget, factor, 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 and then we're going to find our least common denominators. So the first thing, I want to see if my denominators are factored. They are. I can't factor those anymore. And so my least common denominator is going to be my 2 factors multiplied together. So 2n times n plus 6. So I need both of my fractions to be over this. So my first fraction, I'm going to have to multiply top and bottom by n plus 6 because I don't have that yet in my denominator. N plus 6. Okay, so it's really like multiplying by 1. Now I have my new denominator, 2n times n plus 6, and then in the numerator, 3 times n plus 6. We can just leave it like that for now. All right, and then we have our second fraction. I need to multiply the top and bottom by 2n. So now what I have is 2n times n plus 3, and then again, write your common denominator. All right, and then we are going to add our numerators. So this is 3 times n plus 6 plus 2n times n plus 3 all over 2n times n plus 6. Do not cancel the 2n's and do not cancel the n plus 6. These terms right here are being added. That is an addition sign. They are not being multiplied, so you cannot cancel the n plus 6 and the n plus 6. So you can leave it like this, or for me, for my class, I have my students eventually multiply out and combine like terms. So one more step, we're going to distribute. So that's a 3n plus 18 plus 2n squared plus 6n all over. And then we've got 2n squared plus 12n. Okay, I could combine the 6n and the 3n. So just one more step to make this as simplified as possible, just with our we want to combine like terms. So we've got 2n squared plus 9n plus 18 all over 2n squared plus 12n. I can't factor out a 3 out of all of these, and I can't factor out a 2 out of all of these, so I'm just going to leave my answer like this. We do need to see if there's any excluded values. Those are 0, so x can't equal 0, and x cannot equal negative 6. Okay, so excluded values, and then our answer to our addition problem. Okay, I'm running out of a little room, so let me separate this out. This one, factor first, so we need to factor this denominator. So I'm going to rewrite this, and this looks like it's going to factor as b, let's see, minus 6 and b minus 1. We don't have a denominator here, so this is really just over 1. So I don't need to change this fraction right here, but I do need to multiply this fraction by both of these factors. So my least common denominator here is going to be b minus 6 and b minus 1. Okay, so again, keep this fraction the same, but I am going to multiply this fraction top and bottom by this LCD right here. So that means when I multiply, I'm going to get a 2b times b minus 6 times b minus 1, and then don't forget we were adding a b plus 5 all over, and then our LCD. B minus 6, b minus 1. Sorry, that b kind of looks like the 6. Okay, so again, we can distribute this 2b and then multiply the two binomials, combine like terms. I'm just going to stop here. We have shown that we know how to combine the fractions and find an LCD, so we're going to stop here. Last thing I do want to write, though, is my excluded values, and that's going to be positive 6 and positive 1. Okay. All right. Next one, this is going to be addition again. I was supposed to have subtraction, but that's okay. So again, we're going to factor, factor, factor. We cannot factor those. Those are already completely factored. So then my LCD is going to be these two multiplied together. So 2 times b plus 6. All right. So for this fraction, I need to multiply by b plus 6 over itself. So I've got 6 times b plus 6. And then I'm going to add, and then this one I got to multiply top and bottom by 2. So I've got 5 times 2. I'll just write it in parentheses. And then all over, make sure you write your LCD. Okay, and then this one isn't too bad to multiply, so I'm going to write 6b plus 36 plus 10 all over 2b plus 12. And then we could definitely combine those. So this is going to be 6b plus 46 all over 2b plus 12. Ooh, I have all even numbers. So I'm going to factor 2 out. So this is going to be 2 times 3b plus, what is that? 28? Nope. That's going to be 23. Whoops. All over 2 times b plus 6. Cancel the 2's. Okay. Excluded values. X cannot equal negative 6 here. Okay, so that was my final answer right here. Last one. Again, this is just a binomial and a number multiplied together for our LCD. So I want both my denominators to look like 6 times p plus 1. Let's multiply this one, 6 over 6. So that gives me 18 for my numerator. And then this fraction, I need to multiply by p plus 1 over p plus 1. So for this one, I'm going to get 4p plus 4. So I skipped a step this time. I already multiplied through and distributed. And then don't forget, denominator is going to be 6p plus 6. Again, I just distributed. I see these are all even. I'm going to add the 18 and 4. That's going to give me 22. And then I'm going to factor 2 out of everything. So what's left is 11 plus 2p all over 3p plus 3. We're all done. And then my excluded value was just negative 1. That's a negative. All right, so we're done with simplifying. We're done with adding and subtracting. We're going to move on to multiplication. This one, we do not need to find any LCDs. You just factor and cancel. So these ones are pretty simple. First two are going to be multiplication. So I'm just going to multiply across once I've factored. So this one, I'm going to write my first fraction because that's already factored, and then times. Ooh, I can definitely factor this denominator. So n minus 9 up here. And then in the denominator, I can factor out a 5n, and what's left is an n plus 2. Okay, looky here, I can cancel my 5n's. What's left? N minus 9 all over 2 times n plus 2. Leave it there, you are done. My original problem had 2 excluded values. It was 0 and negative 2. So this was your answer, and then those are your excluded values. Okay, we've got one more multiplication. This one, we've got some trinomials, so factor them first. So I've got 3 minus x all over. If I want to factor this, let's see, 4 times 4 is 16, 2 times 8, oh yeah, a 2 and an 8 give me 10. So this is going to be x minus 8 and x minus 2. And then here, when I factor this, okay, now I'm thinking of factors of 24 that are going to add up to 11. Ooh, I know that's going to be x minus 8 and x minus 3. And it's all over x minus 3. And then let's go through, before we even multiply, let's cancel anything that's in a numerator and a denominator. So I can cancel this x minus 3 in here, and I can definitely cancel this x minus 8 in this one here. So all I have left in my numerator is 3 minus x, and all I have left in my denominator is x minus 2. This is your final answer. Our excluded values were only in the denominator. So 8, 2, and positive 3. Okay, so for the next one, it's going to be very similar, except we're dividing. So your first step is to flip the fraction, change to multiplication. Because when we divide by a fraction, you're really multiplying by the reciprocal. So this is really 3 over 9x times, and then we're going to flip this, x squared minus 15x plus 50, all over this new denominator. Okay, then again, factor, factor, factor. So this first fraction stays the same, and we're going to now multiply by, let's see, factors of 50 that are going to add up to 15. We've got 2 and 25. Ooh, 5 and 10. So this is going to be x minus 5, x minus 10, all over. And then I can definitely factor a 3 out of this binomial. So factor a 3 out, and I've got an x minus 5 left over. Okay, so again, if you see anything in a numerator and a denominator, since this is multiplication, I can cancel. So I've got these 3's and these x minus 5's. All I have left is x minus 10 in the numerator, 9x in the denominator. We are done. Your excluded values are a little more complicated for division. It's anything that makes the first denominator 0, and it's anything that makes either the numerator or the denominator 0 for the second fraction, because we are dividing by this entire rational expression. So the entire thing is essentially a denominator. So I'm going to go through. X cannot equal positive 5, positive 10, and 5 was already accounted for, so we're good. We don't need that extra comma. Okay. Last one, division. Again, first step, let's flip the second rational expression. So 1 over m minus 9 times, and then when I flip it, I'm going to write it in its factored form. So I'm going to write this one as my numerator, but I'm going to factor it. So I need to think of numbers that multiply to 90 in order to get me to a positive 1, because this is like positive 1m. And I know that 9 and 10 multiply to 90. I also know they're 1 apart. So that means I'm going to have, as my numerator, m, let's see, this needs to be positive, so this is going to be m plus 10 and m minus 9. Then don't forget, this is going to be your denominator now, m minus 8. Okay, let's go through and see if anything cancels. I've got an m minus 9 in the numerator and denominator, and that's it. So your answer is going to be m plus 10 all over m minus 8. That's your final answer. And then again, let's go through and see, okay, 9 is going to make this denominator 0. We can't have negative 10. 9 we already did, and then we cannot have positive 8. So those are your excluded values. Alrighty. Last ones on here, we have equations now, rational equations. So we need to multiply through by the LCD first, then solve for the variable. So the first thing I want to do is see what are my factors here. I have a 3, an n, a 3 again, so that's a repeat, an n squared, and an n squared. So it looks like my least common denominator is going to be 3n squared. This is my LCD. So let's multiply everything by this number so that I don't have any denominators. So this one, multiply by 3n squared. So I've got the 3 and one of the n's are going to cancel. So I just have an n plus. Let's multiply this one by 3n squared. 3n squared. Well, hey, look, that's going to cross cancel with the denominator. All you have left is 5n plus 10. And then last one, if I multiply by 3n squared, well, the n squareds are going to cancel, and I just have a 3. So it's 3 times n plus 5. So 3n plus 15. All right, let's solve for n. So I've got 6n plus 10 over here, and then I've got 3n plus 15. I'm going to subtract 3n from both sides of the equation. That gives me 3n plus 10 equals 15. I'm going to subtract a 10. 3n equals 5. And then we're going to divide by 3. And I get n equals 5 over 3. All right, so this is my n value. I have solved for the variable. And then I need to go back and see, was this any of my excluded values? So let's see, all these denominators, the only n value that would make them 0 is if n is 0. And that was not my answer, so this is good, and it's not an extraneous solution. Okay, next one, going through and finding my least common denominator. I've got an x, I've got a 4, another x, so I'm definitely going to have an x. I definitely need a 4, and then 2 is just a factor of 4, so that one's okay. All right, so this is my LCD. Let's multiply everything by this. So I'm just going to write it like this, 4x, everything. If I multiply this by 4x, The x are going to cancel, and I'm just going to have to multiply this numerator by a 4. So it's going to give me 12x minus 24. If I multiply this fraction by 4x, well, these are both going to cancel. I just get a 1. And then if I multiply this by 4x, a 2 and a 2 are going to cancel. All I will have left is a 2x. All right, let's solve for x. I'm going to subtract 2x from both sides. I get 10x minus 24 equals 1. Add the 24. So I get 10x equals 25. And then divide both sides of the equation by 10. So it looks like we're going to get another fraction. We're going to simplify this fraction. So this is 5 over 2. Okay, look back at your original problem. Make sure that this is not an extraneous solution. Well, it looks like my only excluded value here again was 0. And so this is not the same number. This is good. This is definitely a solution. All right. Next problem, we have some binomials as our denominators, and it looks like they're the same one. So my LCD here is just, this is like over 1. 1 times this, which is just k minus 3. So this is what we're going to multiply everything by. All right. So if I multiply this first fraction by k minus 3, those are going to cancel, and I just have 1 left. If I multiply this by k minus 3, well, it gives me k minus 3. And if I multiply this by k minus 3, again, the numerator and denominator will cancel. All I have left is a 6. This one's real simple to solve. I've got k minus 2 equals 6. So k equals 8. Let's go back and make sure this was not an extraneous solution. Looks like my excluded value was 3 here. Oops, it's a k. K cannot equal 3. Those are different, so we are good. Okay, and last one. Again, we've got 2 of the same denominator, and this is really just over 1, so we're going to multiply everything by n minus 2. And so if I do that to my first fraction, it's just going to leave me with 1. If I multiply this by n plus 2, nothing's going to cancel, so I actually have to multiply it. 6n, and then it's going to give me negative 12. And then this one, again, if I multiply by n plus 2, it's going to cancel with the denominator, and I'm just going to have a 5 left. So none of these were ones that we needed to use quadratic formula to solve. Sometimes you might, and you might see that on the practice quiz, but for now, these have just been simple to solve for a variable. Okay, so if I combine like terms, I have negative 6n, let's see, minus 11. I'm going to add 11 to both sides, so that's negative 6n, equals 16. And then divide both sides by negative 6. So I get n equals, and if I simplify that fraction, I'm going to get negative 8 over 3. This was not one of the extraneous solutions because my only excluded value was negative 2. All right, so we're good. This is a solution. Okay, thanks for watching, guys. You're going to take a practice quiz soon, so make sure you study these 4 topics for Module 9.